Good day, this is Professor Will, CBMD PhD, and today's Friday, March 25th, 2022. It is 5:37 and 47 seconds, a.m. Eastern Standard Time, and today's research, artificial intelligence versus breast cancer. So let's hop to it here. Artificial intelligence provides accurate breast density classification. Date March 17, 2022. Source: Radiological Society of North America. An artificial intelligence AI tool can accurately and consistently classify breast density on mammograms, according to a new study. Breast density reflects the amount of fibroglandular tissue in the breast commonly seen on mammograms. High breast density is an independent breast cancer risk factor, and its masking effect of underlying lesions reduces the sensitivity of mammography. Consequently, many U.S. states have laws requiring that women with dense breasts be notified after a mammogram so that they can choose to undergo supplementary tests to improve cancer detection. Most commonly, with the American College of Radiology Breast Imaging Reporting and Data System, MyRads, 4-category scale, ranging from Category A for almost entirely fatty breasts to Category D for extremely dense. The system has limitations, as visual classification is prone to inter-observer variability or the differences in assessments between two or more people, and intra-observer variability or the differences that appear in repeated assessments by the same person. And to overcome this variability, researchers in Italy developed software for breast density classification based on a sophisticated type of artificial intelligence called deep learning for convolutional neural networks. A sophisticated type of artificial intelligence that is capable of discerning subtle patterns in images beyond the capabilities of the human eye. The researchers trained the software, known as Trace-4B density, under the supervision of 7 experienced radiologists who independently visually assessed 760 mammographic images. External validation of the tool was performed by the 3 radiologists closest to the consensus on a dataset of 384 mammographic images obtained from a different center. The Trace-4B density showed 89% accuracy in distinguishing between low density MyRads categories A and B and high density MyRads categories C and D breast tissue, with an agreement of 90% between the tool and the 3 readers. All disagreements were in adjacent MyRads categories. The particular value of this tool is the possibility to overcome the suboptimal reproducibility, the visual human density classification that limits its practical usability, and to have a robust tool that proposes the density assignment in a standardized fashion may help a lot in decision making. And such a tool would be particularly valuable, the researcher said, as breast cancer screening becomes more personalized, with density assessment accounting for one important factor in risk stratification. A tool such as Trace-4B density can help our researchers advise women with dense breasts to have, after a negative mammogram, supplemental screening with ultrasound, MRI, or contrast, enhanced mammography. The researchers plan additional studies to better understand the full capabilities of the software. Researchers would like to further assess the artificial intelligence tool Trace-4B density, particularly in countries where regulations of women density is not active, by evaluating the usefulness of such tool for radiologists and patients. Good day, this is Professor Will, CBMD PhD, on microbiology, bioinformatics, and pathophysiology. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.